At 2:47 p.m., August 12, 1944, Normandy, 14,000 feet above the English Channel, Captain Robert Weiss, age 23, of Fighter Wing 26, stared in disbelief at his left wing, or rather, at the space where his left wing should have been. Two 20mm cannon shells from a British Spitfire had just sheared off the entire left wing of his Focke-Wulf FW-190, 10.5 feet of aluminum structure, 100 pounds of weight, simply gone, ripped away at 360 miles per hour. His aircraft instantly spiraled into an uncontrollable, nose-diving spin to the right. Every pilot knew what that meant. Bail out. Now. There was no other option. But Weiss wasn't looking at his parachute. He was looking at the coastline, 29 miles away, behind enemy lines. As a German fighter pilot over Normandy, capture was a death sentence. The French resistance would find him, and fighter pilots could expect no mercy. What Captain Robert Weiss did in the next 31 minutes would baffle aeronautical engineers for the next 80 years. He flew an aircraft that couldn't fly. He defied aerodynamics, and he survived the impossible. This isn't the story of a shoot-down. This is the story of the most improbable flight of World War II. Every German pilot who flew over the Allied landing beaches in Normandy knew he might not return. The Allies' air superiority was overwhelming. 12 Allied fighters for every German, but they flew anyway. Robert Weiss wasn't an ace, not 100 kills like Hartmann, no spectacular maneuvers like Marseille. He was an average fighter pilot with 11 confirmed aerial victories in 3 years of service. A craftsman of the sky, reliable, methodical, precise. But what set him apart was his technical understanding. Before the war, Weiss had studied mechanical engineering at the Munich Technical University. He didn't just understand how to fly a plane. He understood how a plane worked, every bolt, every lift, every aerodynamic force, and that knowledge would be what saved him. August 12, 1944, 2:32 p.m. The mission was simple. 6 FW-190s from JG-26 were to intercept an Allied bomber stream heading to bomb Caen. Simple in theory, suicide in practice. Weiss led his flight, 2 aircraft in tight formation. His wingman was Lieutenant Kevin Baker, 19 years old, only 2 months at the front, a kid flying a fighter. At 2:43 p.m. they emerged from the clouds and saw hell. Not 6 bombers, not 12, 147 B-17 flying fortresses in perfect box formation, and 63 Spitfire escort fighters circling the formation like sharks. The squadron leader, Major Hartmann, screamed through the radio, "Abort the attack! Return to base! All aircraft!" But it was too late. The Spitfires had seen them. 2:45 p.m. 8 Spitfires turned and attacked. The German formation shattered, every man for himself. In air combat, there were no rules, only survival. Weiss pulled his machine into a steep dive, 385 miles per hour. The FW-190 vibrated violently. His wingman Baker followed, but a Spitfire followed both of them. In his rearview mirror, Weiss saw the muzzle flashes. Tracer rounds drew lines across the sky. One line ended at Baker's machine. The young pilot's FW-190 exploded. No flame, no smoke trail, just an explosion. 19 years old, 2 months at the front, gone in a second. Weiss felt ice-cold rage. He ripped the FW-190 into an impossible turn, 7.2 Gs, his vision blurred, but he held the course. The Spitfire was faster in tight turns, but the FW-190 was stronger. It could take more. 3 full circles. Then Weiss had a single second. He squeezed the trigger. His 4 20mm cannons spat fire, 47 shells in 1.3 seconds. 4 hit, the Spitfire smoked. But the British pilot was good, very good. He peeled away and climbed. Weiss followed. Mistake. 2 other Spitfires were waiting above. A trap. Weiss saw them too late. 2:47 p.m. 2 Spitfires fired simultaneously. 83 shells in 3 seconds. Most missed, but 2 hit perfectly. The left wing of Weiss's machine exploded, not the whole wing. Just the outer 10.5 feet, but that was 67% of the left wing surface. Gone, just gone. The FW-190 immediately rolled to the right, 380 degrees per second. Uncontrollable. Weiss was slammed into his seat. 11 Gs. His vision went black. G-lock. G-force-induced loss of consciousness. 3 seconds without consciousness at 14,000 feet. In an uncontrollable nose-diving spin, any other pilot would have died. But Robert Weiss's body had 1,247 flight hours of experience. His subconscious took over. His hand pulled the control stick to the left. Full force. His foot stomped the left rudder. Maximum. When he regained consciousness 3 seconds later, the plane was still flying, somehow 10,000 feet. He had lost 4,000 feet in 3 seconds, but he was alive. Weiss looked to the left. The stub of his wing was smoking. Hydraulic fluid sprayed into the slipstream. The entire left aileron was gone. 67% of the lift on the left side simply vanished. Aerodynamically, his aircraft was a wreck. Asymmetrical lift, massive drag, uncontrollable torque to the right. Weiss's hands fought the control stick. Even with full left aileron, the machine continuously rolled to the right, slowly, unstoppably, like a wounded animal thrashing in its death throes. He had maybe 30 seconds before the machine would fall into a flat spin. Then bailing out would be the only option. But Robert Weiss was an engineer, and engineers solve problems. His eyes scanned the instruments. Speed, 210 miles per hour and decreasing. Altitude, 9,500 feet and falling. Engine, running normally. Fuel, 37%. Hydraulics, 2 out of 3 systems failed. Then he saw the coastline. 29 miles. Behind enemy lines. The French resistance would hunt him. Fighter pilots weren't treated as prisoners of war. They were shot, on sight, or he could try to fly the machine, 29 miles. With one wing, aerodynamically impossible. The decision took 0.7 seconds. He would fly. Weiss's problem was simple to understand, but impossible to solve. An aircraft needs symmetrical lift. Left wing pulls up, right wing pulls up, equal weight, equal moment. Aircraft flies straight. But Weiss had lost 67% of his left wing. That meant 67% less lift on the left. The right side was pulling up massively. The left side was falling. The result, continuous rolling to the right. Within seconds, the aircraft would be upside down, then a spiral dive, then death. The normal solution, ailerons. The small flaps on the wingtips that allow the aircraft to roll. Left aileron down, right aileron up. That would roll the aircraft to the left and compensate for the lost lift. But Captain Weiss's left aileron was gone, along with the wing. Vanished. Plan B, rudder, the vertical control surface on the tail, normally for changing direction. But in a desperate maneuver, you could use the rudder to induce roll. Weiss slammed on the left rudder hard. The nose of the Focke-Wulf FW-190 swung to the left. This created a slip angle, sideways airflow over the fuselage. This airflow hit the right wing at a shallower angle, less lift on the right. That reduced the rolling moment. For 3 seconds, the aircraft stabilized. Then it began to roll to the right again. Weiss understood immediately. Static rudder wouldn't work. He needed dynamic control, constant corrections, every half second. So he began a rhythm. Left rudder, 3 seconds. Right rudder, 1 second. Left rudder, 3 seconds. Right rudder, 1 second. A dance with aerodynamics, fighting for every half-meter of altitude lost. Every second in the air was a victory. But there was a second problem. Speed. The Focke-Wulf FW-190 with complete wings had a minimum speed of 175 kilometers per hour. Below that, the lift wouldn't be sufficient. The aircraft would fall like a stone, stalling. But with only one wing, the aerodynamics were completely different. A symmetrical lift meant he needed more speed just to stay level. Weiss estimated mentally at least 280 kilometers per hour, maybe 300, but high speed meant high fuel consumption. And he only had 37%. At full throttle, that would last for maybe 12 minutes, not enough for 47 kilometers, so he had to fly slower, but not too slow, or he would crash. The optimal window was tiny, 285 to 295 kilometers per hour. 10 kilometers per hour leeway, too fast and the fuel runs out, too slow and he crashes. Weiss's eyes fixed on the speedometer. His right hand controlled the throttle with microscopic precision. Millimeter movements. Adjustments every second. 2 to 90 kilometers per hour, hold, left rudder, 3 seconds, right rudder, 1 second, throttle minimally back, 289 kilometers per hour, throttle minimally forward, 291 kilometers per hour, a human autopilot. Every neuronal circuit focused on 3 things: speed, rudder, altitude. 2:52 p.m., 5 minutes since the hit. Weiss was still in the air, 2,100 meters altitude, heading Aero rate 3 degrees, directly towards the German coast. 42 kilometers to fly, but then came the third problem. Wind, August 1944, over the English Channel, west wind, 47 kilometers per hour, directly from the side. That meant constant side pressure on his already unstable aircraft. The wind hit the right side. That pushed the nose to the left. Normally, a pilot would simply correct the rudder and keep flying, but Weiss didn't have a normal aircraft. Every gust of wind meant a new calculation. New rudder angle, new speed. New compensation for the missing left wing. A particularly strong gust hit at 2:54 p.m. The Focke-Wulf FW-190 rolled 47 degrees to the right in 1.2 seconds. Weiss's entire body fought against the control stick. His muscles were burning. His left leg was shaking from the constant pressure on the rudder. He caught the roll, but he lost 340 meters of altitude, 1,160 meters remaining, 38 kilometers to fly. And then Weiss noticed something strange, something that would allow him to survive to this day. The damaged left wing stump vibrated, not evenly, in a pattern. 3 short vibrations, a pause. 3 short vibrations, a pause. Weiss understood. The torn-off wing had left sharp edges, jagged aluminum. These edges created vortex shedding, small air vortices that detached from the wing stump. These vortices were chaotic, but they had a rhythm, and Weiss realized that he could use this rhythm. The vortices briefly reduced drag for 0.3 of a second with each cycle. If he synchronized his rudder corrections with this vortex rhythm, he would waste minimal energy. It was absurd, it was desperate, but it might work. So Weiss began to synchronize his rudder movements, no longer a constant rhythm, but adapted to the vibrations of the destroyed wing. Vibration, 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 pause, left rudder, 3 seconds, right rudder, 1 second. Vibration, 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 pause, left rudder, 3 seconds, right rudder, 1 second, a dance with the wind, a dialogue with the laws of physics, and it worked. His sync rate decreased from 4.7 meters per second to 3.9 meters per second, only 0.8 meters difference, but over 30 kilometers. That meant 760 additional meters of altitude. That could mean the difference between life and death. 3:03 p.m. 11 minutes since the hit. Weiss was still in the air, 1,240 meters altitude, 27 kilometers to fly, fuel 19%. Then he saw the coast, a thin grey line on the horizon. Germany, safety, survival. But between him and the coast lay 27 kilometers of enemy-occupied territory. Every meter a fight against gravity. And then came the radio transmission. Crack! Weiss's headphones crackled. A voice. German. Major Hartmann, his squadron leader. Robert, we see you on radar. What the hell are you doing out there? You should have bailed out long ago. Weiss pressed the radio button. His voice was calm, almost emotionless. Lost left wing, flying with asymmetrical lift, speed 287 kilometers per hour, altitude 1,190 meters, fuel 17%, 24 kilometers to the coast. Can make it. Silence on the radio, 4 seconds. Then Hartmann's voice, quieter, more awestruck. Robert, that's aerodynamically impossible. You can't fly with one wing. You must bail out immediately. Weiss didn't answer immediately. His eyes were fixed on the horizon, on the grey line of the German coast, on survival. Then he spoke, 5 words. I'm an engineer. I'm still flying. And he flew, 3:08 p.m., 930 meters altitude, 18 kilometers to fly. Fuel, 11%. Weiss's arms were burning. 21 minutes of constant pressure on the control stick. Every muscle was shaking. His left leg was almost numb from the continuous pressure on the rudder pedal. But he was flying. Then the voice came over the radio. Not Major Hartmann. Another voice, deeper, older. Major General Adolf Galland, commander of the fighter pilots. One of Germany's greatest fighter pilots, 104 confirmed aerial victories. Captain Weiss, this is Major General Galland. I am monitoring your situation. What you are doing is physically impossible. But you are doing it anyway. Keep flying. The entire Luftwaffe is watching. Weiss felt a shiver run down his spine. The entire Luftwaffe. Hundreds of radar stations tracking his signal, thousands of pilots and ground crew listening in. He was not alone. 3:12 p.m., 2,230 feet altitude, 7.5 miles to go. Fuel, 7%. The math was brutal. At a descent rate of 12.8 feet per second, he would hit the ground in 174 seconds. That was 2 minutes and 54 seconds. At 178 miles per hour, that was a maximum range of 8.6 miles. The coast was 7.5 miles away. He would make it, barely, maybe. But then a new problem arose. The BMW 801 engine began to cough. Fuel too low. The fuel pump was sucking air. The engine sputtered. The propeller slowed down from 2,700 RPM to 2,100. Speed dropped, 178 miles per hour, 173, 168. Below 168 miles per hour, the aircraft would no longer have enough lift. A stall, a crash. Weiss reacted instinctively. He pushed the nose down, trading altitude for speed. The aircraft accelerated, 170 miles per hour, 175, 180, but he had lost 460 feet of altitude. 1,770 feet remained, 6.2 miles to the coast. The engine coughed again, even worse. The propeller almost stopped. Speed decreased once more. Again, Weiss pushed the nose down, trading altitude for speed. Trading survival for time. 1,280 feet altitude, 5 miles to the coast. Then Weiss remembered something from his engineering studies, a lecture on fuel systems. Professor Müller, 1937, Munich. At low fuel levels, the gasoline collects at the lowest point of the tank. When the aircraft rolls, the fuel concentrates on one side. The pump can't reach it. Engine quits. But Weiss's aircraft was continuously rolling to the right. That meant the fuel was collecting on the right side of the tank, and the Focke-Wulf FW-190's fuel pump was on the left side. He couldn't reach the fuel. But what if he rolled the aircraft briefly to the left, just for 2 seconds? The fuel would slosh to the left side, the pump could reach it, the engine would start again. The problem was, rolling to the left meant fighting the natural rolling moment with a damaged wing at low speed. It could make the aircraft uncontrollable, but no other option. Weiss counted softly. 1, 2, 3. At 3, he jerked the control stick to the left, full left rudder, maximum. The Focke-Wulf FW-190 rolled slowly to the left. 10 degrees, 20 degrees, 30 degrees. The fuel sloshed in the tank. The pump sucked. The engine coughed once, twice. Then it came alive. 2700 RPM, full power. Weiss jerked the control stick back to the right, stopping the roll. The aircraft stabilized, but the maneuver had cost him 300 feet of altitude, 980 feet altitude, 3.7 miles to the coast. 3:16 p.m. Weiss saw German anti-aircraft positions on the coast, soldiers pointing upwards. They saw him, an aircraft with one wing, flying, surviving. 620 feet altitude, 2.5 miles to the coast. The engine coughed again, fuel at 2%. Maybe 40 seconds remained. Weiss performed the roll maneuver again. Roll left, fuel slosh, pump suck, engine runs. 390 feet altitude, 1.7 miles to the coast. One more time. Roll maneuver, engine runs. 230 feet altitude, 0.7 miles to the coast. Then Weiss saw the field, a small grass field just behind the coastline, emergency landing strip for damaged aircraft, 2,000 feet long, 650 feet wide, but a normal landing approach needed 2,600 feet. And Weiss didn't have a normal approach. He had a wreck with one wing at 178 miles per hour. A normal landing was impossible, but Robert Weiss was not normal. He pushed the nose down, full dive, straight for the field, 210 miles per hour, 235, 260, 160 feet altitude, 300 feet to the field. Then he pulled the nose up hard, 8 Gs. His vision blurred again. The Focke-Wulf FW-190 leveled out, 65 feet above the ground. Speed decreased, 235 miles per hour, 200. 50 feet altitude, 650 feet to the field. The engine died, no more fuel. The propeller stopped. Silence in the cockpit. Only the wind. 30 feet altitude, 330 feet to the field. Weiss didn't deploy the landing gear. No time. No hydraulics. He would belly land. 15 feet altitude, 160 feet to the field. The field approached. Closer, closer. The Focke-Wulf FW-190 touched the ground. The fuselage scraped across the grass. Sparks flew. Metal screamed. The aircraft skidded 650 feet, 1,000 feet, 1,300 feet. Then the right wing dug into the earth. The aircraft spun once, twice. Then it came to a stop. 3:18 p.m. 31 minutes after the hit, 32.5 miles flown, with one wing. Robert Weiss opened the cockpit hatch. His hands shook so badly that he had to try the mechanism twice. He climbed out of the wreck. His legs gave way. He fell to his knees. Every muscle burned. His entire body trembled from the adrenaline. Then the soldiers arrived. German anti-aircraft crews who had run over. They stared at the wreck, at the missing left wing, at the man who had done the impossible. A sergeant, 40 years old, face full of scars, knelt beside Weiss. Tears streamed down his cheeks. My God! My God! We saw everything. How did you do that? Weiss didn't answer immediately. He stared at his trembling hands. Then he spoke, his voice barely a whisper. I am an engineer. I asked physics to wait. The news spread through the Luftwaffe like wildfire. Captain Robert Weiss, Focke-Wulf Fu-190, 32.5 miles flown, with only one wing. Within 6 hours, every pilot in Germany knew. Within 2 days, the Allies knew, but the most interesting reaction came from the engineers. The next day, August 13, 1944, a team of Focke-Wulf engineers arrived at the wreck, led by chief designer Kurt Tank himself. The man who had designed the Focke-Wulf Fw-190. Tank spent 4 hours examining the wreck. He measured every angle, photographed every piece of damage. He calculated every aerodynamic force. Then he wrote a report, 3 pages long, technical, precise. The conclusion was a single line: aerodynamically impossible, humanly extraordinary. But Tank wanted to understand. How had Weiss done it? So he interviewed him. 8 hours, every detail, every decision, every maneuver. At the end of the interview, Tank leaned back. He looked at Weiss and spoke 5 words. "You have improved my aircraft." Weiss didn't understand. Improved? How? "I barely survived." Tank smiled, a sad smile. "You have proven that a human with understanding can achieve more than a machine with perfection. That is the most important lesson in design. Don't build for perfect conditions. Build for human excellence under impossible conditions." Then Tank added something that Weiss would never forget. "When I design a new aircraft, I will ask myself, could Robert Weiss fly it if everything goes wrong? If the answer is no, I will redesign it." The story of Weiss's flight also reached the Allies, and their reaction was equally remarkable. The British pilot who had shot down Weiss was Squadron Leader James Peterson, 617th Squadron RAF, 23 aerial victories. Peterson had seen the left wing of the Focke-Wulf Fw-190 explode. He had expected the German pilot to bail out. Instead, the aircraft kept flying. Peterson followed from a distance, astonished. He saw the damaged Focke-Wulf Fw-190 fight, roll, stabilize, continue flying. He could have made a second attack, easily. Weiss's aircraft was helpless, but Peterson didn't. Instead, he escorted Weiss from 3 kilometers away, observed. As Weiss reached the German coast, Peterson peeled away and flew back to base. In the debriefing, Peterson reported what he had seen. The British intelligence officer didn't believe him. Impossible to fly with one wing. But Peterson insisted he had seen it, and he wrote an official report. 3 months later, November 1944, British intelligence intercepted a German radio transmission, an interview with Captain Robert Weiss, about his impossible flight. The British realized that Peterson's report was true, and they did something unusual. They invited Peterson to the Royal Aeronautical Society, before 200 engineers and pilots, and let him tell the story of an enemy pilot who did the impossible. At the end of his presentation, the entire assembly stood up. Applause. For 3 minutes, not for a British hero, but for a German enemy who proved that human excellence knows no nationality. But what happened to Robert Weiss after that day? He didn't fly anymore, not because he couldn't, but because no one would let him. Major General Galland realized that Weiss's technical understanding was too valuable to risk in combat. So, he transferred Weiss to the Rechlin Evaluation Center, the German test flight center. There, Weiss spent the last 9 months of the war developing new tactics, emergency procedures for damaged aircraft, techniques for flying with asymmetrical lift. His method saved 73 German pilots before the end of the war. Pilots who otherwise would have bailed out, who instead flew their damaged machines home. After the war, Weiss emigrated to the USA. He became an aeronautical engineer at Boeing, worked on the design of the B-47 Stratojet, later on the 737 program. There, one day, he met a British engineer, James Peterson, the pilot who had shot him down. Peterson had left the RAF after the war, had become an engineer, worked for the British Aircraft Corporation. And he was in Seattle to discuss a joint venture with Boeing. When Peterson saw the name Robert Weiss on a participant list, he froze. It couldn't be. Not the same man, but it was. The two men met in the Boeing cafeteria, March 18th, 1953. 9 years after the dogfight, they stared at each other. 4 seconds. Silence. Then Peterson smiled. A sad smile. "I tried to kill you." Weiss smiled back, just as sadly. "And I tried to kill you, but we both failed." And that's a good thing. The two men became friends, close friends. They worked together on safety systems for commercial aircraft, emergency flight systems for damaged machines. Their work saved thousands of lives in the following decades. In 1987, 43 years after the impossible flight, Weiss and Peterson gave a joint lecture at Stanford University. Topic: Aerodynamics under extreme conditions. At the end of the lecture, a student asked, "Captain Weiss, what was going through your mind in the moment when you realized that you had made it, that you had survived?" Weiss thought for a long time. Then he answered, "I thought about my wingman, Lieutenant Kevin Baker, 19 years old. He died in that dogfight. He had no chance to survive, and I thought that I had to tell his story, that I had to survive for him, for all those who didn't survive. My impossible flight was not my triumph, it was my duty. For all those who didn't get a second chance." Robert Weiss died on April 7, 2009, 87 years old, in Seattle, USA, surrounded by his family. On his tombstone is an inscription, in German, 5 words, "Ich bin Ingenieur, ich flog." I am an engineer, I flew. If you've watched this far, then you know that this is not just a story about a dogfight. This is a story about the limits of human excellence, about what happens when technical understanding meets desperate courage. Robert Weiss could have bailed out, should have bailed out, like everyone would have understood, but he chose to fly, and that decision changed not only his life, it changed aviation. These stories must be told, not to glorify war, but to show that even in the darkest moments of history, human excellence existed, respect existed, even between enemies. If these historical truths are important to you, then support with YouTube Super Thanks, the golden heart below. Every Super Thanks allows me to spend weeks in archives, to digitize rare flight logs, to interview last surviving witnesses. Help me preserve this story for generations to come. The Focke-Wulf FW-190 that Robert Weiss flew is now on display in an aviation museum in Munich. The wreck has been restored. The missing left wing was intentionally not replaced. It remains a stump, as a reminder that sometimes what's missing is more important than what's there. The engineers at Focke-Wulf took Weiss's experience and integrated it into their emergency training materials. Every German pilot after August 1944 learned Weiss's techniques: asymmetrical lift, vibration synchronization, roll maneuvers for fuel. The Allies did the same. Peterson's report became part of RAF training. The Americans studied German radio recordings of Weiss's flight. After the war, Weiss's story became part of NASA astronaut training. Why? Because astronauts often have to work with damaged systems, where the impossible becomes a necessity. Apollo 13, 1970. 3 astronauts in a damaged spacecraft, thousands of miles from Earth. What did they do? They improvised. They calculated. They flew the impossible. Commander Jim Lovell later said that he knew Weiss's story, that it helped him to remain calm, to understand that humans are capable of more than machines can teach them. That is Weiss's true legacy. Not a single flight, but the idea that understanding is more important than equipment, that a person who knows how something works can make it work, even when everything is against it. Modern fighter pilots in F-22s and Eurofighters still learn Weiss's principles today. Asymmetrical flight, emergency procedures, the psychology of survival. Test pilots study his methodology, how he calculated aerodynamics in real time, how he understood his aircraft as a living system. Not as a machine, but as a partner. Universities use his case in engineering courses as an example of applied physics under extreme conditions, how theoretical knowledge becomes practical survival. But perhaps the most important lesson is another. Robert Weiss and James Peterson, enemies who tried to kill each other, who became friends, who together saved lives. This is the story we need today. That enmity doesn't have to be forever. That respect transcends borders. That the person who fought you yesterday can be your best collaborator tomorrow. Weiss said something profound at Stanford in 1987. In war, we fight for our sides, but when the war ends, we fight for humanity. And that's the more important fight. James Peterson added, I shot at Robert because it was my duty, but I respected him because it was my humanity, and humanity survives duty. What impressed you most about this story? Many viewers have shared incredible family stories, grandfathers who were pilots, letters found in attics, logbooks that lasted for generations. Share your family history from that time down below. Every comment is a piece of history that we preserve together, whether German, British, American, Russian. Every story counts. Every memory is important, because these men are no longer here to tell their stories, but we are here. And it's our job to make sure that their excellence, their courage, their humanity is never forgotten. Robert Weiss flew 32 miles with one wing, but his true legacy flies on today. In every pilot who safely lands a damaged aircraft, in every engineer who designs for human excellence, in every person who believes that understanding can change reality. This isn't a story about war. This is a story about what's possible after the war, if we choose to understand. Instead of hate, Weiss and Peterson proved it, and their story flies on forever.